Good evening. You're on the Smoking Section, and I'm very happy to have a guest tonight, Keldin Sergheyev. And Keldin, you've been on before. How many times?
Once before.
Once before. There was something that Keldin is a scientist, a student at MIT, and a strong proponent of nuclear energy.
That's correct.
Is that mostly for environmental reasons, or is it for economic and environmental reasons, or
All of the above.
are there any other reasons to,
Safety, reliability, bringing people out of poverty.
you think that could help, for example, particularly
Yeah.
in the underdeveloped world,
Yeah.
like Africa?
Sure, many African nations, many Southeastern Asian nations definitely want to bring lights to places where there's no light.
Well, they have, right
Clean
now, they
water.
have plenty of cell phones, that's for sure, right?
Some of these countries do, yes.
And does that include iPhones?
I have no idea. I haven't the faintest idea what kind of phones they have.
In the United States, I don't think energy is really a big deal, frankly. I mean, I don't think we have enough energy as it is. We use too much as it is, right?
That's up for debate.
Yeah.
I think everyone can benefit by using more energy. Actually.
Is that right?
Yeah.
To do what? I mean, don't, so we walk less, so we think less, so we, there's so many things. I mean, it seems to me there's too much energy in this country.
You could view it that way. I mean, you can't necessarily dictate how people are going to use energy, but you have to realize that a large portion of the energy that you use isn't going to frivolous activities. It's going to producing useful products and
Food, for example.
sure, or
Which is
clean water,
Right.
or refining substances or medication, making medications. So, or electric lighting, or
Well-
science even. More research.
Right. Of course,
Energy can be used in all kinds of productive
I'm pretty
ways.
much of a naysayer. I think there's too much research also. But, I mean, people at MIT, they don't want to hear that, I guess not, right?
I don't mind hearing it. We can talk about it.
Well, I mean, because, for example, I think a lot of science in this day and age, and maybe always, you may be going back to Galileo, I mean, has been funded. And, one of the big things in science, of course, is to get funding. And I think to a large extent, as a lot of people think politics has been corrupted by funding, I think a lot of science has.
Up for debate.
Up for
certainly.
debate. I mean, certainly,
Debate.
there's a huge amount of money that the National Institutes of Health throws at academic institutions, and they absorb them, and they fight, all the PhD students fight to do any kind of research they can put them on the map. And I think a lot of the research is rather frivolous, and and I have a bug about it, because a lot of funding goes for what is called tobacco research. And usually what that means is, if you are a researcher and come up with some kind of evidence, putative evidence, which some kind of data that shows secondhand smoke is worse than they thought it was, or third-hand smoke, or smoking causes some disease, or you can somehow, through statistical legerdemain, come up with and say, well, if someone smoked during her pregnancy and then her son gets into trouble at the age of 18, it's because she smoked during pregnancy. That there's a higher percentage. Do you follow what I'm saying? And do you see why that bothers me?
Yeah, I understand that would, if that's what you perceived was happening, that would certainly
Well, I
bother
mean,
you.
what do you think? You're in the field of research, and you're in one of the...
I don't identify with the National Institute of Health. I can't be a representative for all science everywhere.
Right.
But and I don't really know much about the politics of that institution or the funding goals. So I'm not in any position to either defend it or attack it.
Well, the last time...
All I can espouse is what I would believe to be the best course of action for scientists, which is to do science according to the scientific method, regardless of where your funding comes from.
But politics enters into all fields of human endeavor, including science.
I suppose so. I mean, yeah, there are discredited scientists, and there also, as there are discredited members of any other field.
Well, one thing that you said that on the show the last time that kind of stuck in my craw.
In your craw, okay.
Yes, and that was, for example, in physics, if I take a ball and throw it up in the air, let's say we did that as an experiment here in this studio, and I threw a ball up 10 times, and it came, my guess is it would come down 10 times.
Yeah.
Right now.
Yeah. I think that's a safe guess.
Okay, so.
I put a high probability on that outcome.
Now, for example, Jim Jones in British Guiana, I think, around 1980, administered cyanide in Kool-Aid to about 500 people.
I think it was Flavor Aid, but yeah.
Okay.
Kool-Aid gets a bad rap because of that.
Yes, that's true. They use it a lot, drink the Kool-Aid. And
yeah, that must be terrible marketing for them.
Right. I don't know. They say any publicity is good publicity. Right?
Yeah.
But I don't think that's really true. Any publicity. I mean, if if you're trying to get elected president and it turns out you're a pedophile, it usually doesn't help.
Yeah, typically not. We'll
but
see
my
how
point
it
is,
affects Donald Trump.
so why is it that, for example, the vast majority of cigarette smokers, lifelong cigarette smokers, do not get lung cancer? The vast majority don't.
Right, so why isn't this...
Why do we say, well, cigarette smoking causes lung cancer? I mean, how do we, and of course then they take a cop out and they say, well, it's a risk factor.
Right.
And that's
Who's
how...
they?
Well, the powers that be in the medical profession.
Okay,
I mean,
don't know who that is.
Well, let's say the National Institutes of Health, National Institutes of Medicine, National Institute of Medicine. But the last time you were on this show, you said, well, biology does seem to work along statistical lines.
Yeah, I've actually, since then I would say that I've adopted that position even more strongly.
Oh my gosh.
Yeah. Believe me.
Well, tell me a little about it.
Okay, so I think that this is part of a broader issue, which is not just restricted to biology, I'm afraid, but to all of the empirical fields, everything scientific, which is that the low-hanging fruit has already been taken.
Mm-hmm.
The effects that are so obvious have already been described.
Okay.
Right?
Like gravity, for example.
Right, that...
By Dr. Newton.
Yeah. You don't need to do the statistics correctly to get a theory about gravity. And it used to be the case that there were so many low-hanging fruit as far as empirical discoveries were concerned that you didn't even have to have the proper statistical analysis, or really any statistical analysis. The effect was so obvious that you couldn't help but describe it.
Like the effect of cyanide on a large population.
Right. You could have said things like cyanide kills and probably gotten by without any further qualification.
Right.
So...
But I mean, when
those days are over.
Okay.
There's no more low-hanging fruit. At least I don't think so. Maybe occasionally we hear about some discovery that was just lurking under our noses all this time and we've just found it recently. But for the most part, the effects that have yet to be described are not low-hanging fruit. They are not obvious, and you need a lot of data and a lot of statistical analysis to tease out the effect.
Right.
So any observation you could say is due to multiple factors influencing it, and we took care of all the biggest factors, right? We know what affects, the number one effect on a ball falling is gravity, right?
Right.
But there might be other effects like little eddies in the air or something. Well, we still haven't really described turbulence very well. We're trying, but it turns out that it's not that important in the motion of a ball falling. The most important thing is gravity. I think a lot of the effects left in the world that we are describing are a bit like turbulence. They're much smaller,
Well,
and
let
in
me-
order to get
let me
that
just-
effect, you need to tease
I don't mean
out
to
the
digress,
data.
but what is gravity? I mean, it's a pretty strange phenomenon. Is it
I am
like
not
magnetism?
qualified to answer that question.
I mean, everyone
I
thinks
could
it's
tell
very
you what I've
simple.
learned. I could tell you about, you
Well-
know, the like 5 sentences of general relativity.
No,
that
I'd rather
know,
not, because I don't
Oh,
want
it
to
would
get too
be-
far
it'd be
off
really
into that. But
fascinating.
why, when I take this ball, it does go down toward the floor? I mean, that's a pretty interesting thing. I mean, it's
Yeah.
not. Is it like magnetism, or what is it? And what is this so-called force? And what is a force?
Well,
What does that mean? Something.
I'll
is
give
a
you
force?
one sentence that hopefully will blow your mind because it blew mine. As far as we can tell, gravity is not a force at all.
Okay.
It's an illusion.
It's an illusion.
It is a curvature in space-time.
Okay.
But if you want me to get into
let's
that,
just
that's
I don't
really-
want to get you into that, but I am interested in this. So does that contradict Dr. Newton?
No.
It doesn't contradict.
Nope.
But did he describe it as a force?
Whether it is or is not a force is kind of irrelevant. What matters is whether or not your experiment is falsified. And if you take the universal law of gravitation proposed by Newton with the constant of gravitation, I believe that was measured originally by Cavendish, and you do an experiment on any falling mass, then your results will obey that equation.
Okay, but my question then
Whether or
back to
not you describe it as a curvature in space-time.
and whether you do a statistical analysis. You don't have to throw balls up for a long period of time to falsify or confirm his theory.
Well, there's no confirmation, there's only falsification.
Okay.
Yeah. No
Okay.
theory is ever confirmed. You can only ever falsify.
Well, let me ask you then, so why is it back to statistical analysis? I mean, as I say, the vast majority of lifelong heavy smokers do not get lung cancer, yet the medical profession says smoking is a cause of cancer. So how do we, at what point do we say statistically we determine, well, it happens enough times that we'll call it a cause?
Right. Well, I honestly think the issue here is a breakdown of communication between the scientific community and the non-scientific community, or maybe those who have studied statistics and those who have not. I think it's often the case that there are misunderstandings when scientists say things and the public hears it like, what do you mean evolution is just a theory? Well,
Right.
that's that will throw a lot of lay people off. Or what do you mean general relativity is just a theory? What do you mean gravitation is just a theory? I see it myself. What do you mean that? And I think that it's often the case as well that scientists might attempt to communicate with the public and it might backfire. I don't know who said that smoking causes cancer. If you want to be perfectly accurate about it,
Yes.
you can't really say it that way and have it be a scientific statement. A scientific statement might be that smoking is highly correlated with cancer, and we are aware of many possible mechanisms by which smoking could lead to whatever genetic degradation or mutation causes cancer.
Right, except
That would be a more scientific statement.
right, but that is not the statement that is made, and that is not the
By
statement
whom?
by just about anybody in the medical profession, and certainly anybody in the profession of public health.
Right. Well, I don't want to be an apologist for that community because I have my gripes about the medical profession as well. But they interface with the public
Right.
perhaps more than any other scientist, perhaps. I have to think about that for a bit, but which means that probably a lot of compressions of scientific statements are made by people in the medical profession, compressions that are intended to communicate rather complicated ideas
Right,
to
right.
people who don't know about things like statistics and the scientific
Well,
method.
I mean, there was a great biostatistician by the name of Joseph Bergstrom, and
Tell me about it.
well, I don't even think I may have his name correctly. It's Bergstrom, and he was one of the people who challenged the statistical analysis that purported to show that smoking caused cancer, caused lung cancer. And one of the statements he made is it's a matter of biology, not statistics. So when you use statistics to determine causality, it always gets really tricky, and that's why often...
Causation?
Yeah, that's why often people want to see the exact biological mechanism
Right.
rather than a simple correlation, or they rather see it in, certainly, for example, animal studies, which
Right.
are certainly statistically are much easier to deal with animal populations, especially if they're captive.
Right, we can control more variables, yeah.
So why do you still say that now you're like, so in other words, the analyses that we're talking about, according to you, are not low-hanging fruit, and they're only going to be, let's say, available to us by these statistical analyses? Is that what you mean when you say...
Yeah, that's pretty close to what I mean. I think that probably the smoking lung cancer issue is one of those cases that just happens to fall on sort of the divide between these two eras in science, the low-hanging fruit era and the, wow, we're going to have to do a lot of statistics era.
Right, right. Well, the thing is, certainly in terms of medicine, that was, I think, the turning point of medical research, where they decided, well, we can't show a biological mechanism. We're not really successful with animal studies. We can't get animals to get lung cancer, but we do have a correlation, and the correlation, shows that even though a minority of smokers get lung cancer, it's a higher percentage than of non-smokers. So then we say, or has been said, that smoking causes lung cancer. We decide to say, we infer causality. That's where it changed. The whole...
Causation.
Right.
Causality is something different.
Well, I mean, but they're claiming some people claim that through statistics you can determine causality.
Causation.
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 Oh, I see. Those are two different...
Yeah.
And would you agree with that, or would you disagree with that?
Can you restate the question?
Well, some people say that if the statistical relationship is high enough, then we can say that it has been medically proven that X causes Y. If there is a strong enough statistical correlation.
I don't know that I'm really qualified to answer that question.
Because your field is not medicine and biology.
It interfaces a little bit with biology and medicine. But mainly, I don't know that I'm necessarily the best person to say how scientists should communicate with the public. I know I have opinions about how nuclear scientists should communicate with the public.
Mm-hmm.
But I don't know that I can make a pronouncement about how all scientists. I personally would, if you were to ask me, as a scientist, what would you say? I would say, okay, I wouldn't use the word causation.
Right.
I would avoid that. I would try to be as precise as possible. But lots of lay people lose their attention if you try to be as precise as possible, and you want to communicate results to them that will be useful in their lives.
Or change their behavior, for example.
give them the opportunity to change their own.
Right, right.
Right. So it becomes sort of a moral issue. Do you sacrifice precision of speech in order to possibly do some good by making a concept somewhat more palatable or approachable to a layperson? Or do you just maintain a strict precision of speech and
Right.
never say something that is patently false?
Yeah. Well, I mean, that's, I guess, an ethical question that people in the scientific field have to think about. But then again, they also have to think of funding, and they also need to think, or they want to think about recognition and all of these kinds of things. And that tends to make them, in my opinion, err on the side of, well, let me say something that's good in a press release, and that I'm going to get in the paper, and that I might get funding, and I'll become a big shot.
Well, let me tell you, if you want recognition, you don't go into science.
Aha. Well, I mean,
There's so many easier ways to gain recognition. So,
I guess you might think that I have somewhat of a dim view of science.
maybe scientists.
Well, I don't know.
I actually think that you have a very deep respect for science.
Oh, well, thank you.
I think that's one of the things that we share, actually, is a deep respect for the scientific.
Well, I mean, if you talk about, for example,
scientists,
the
maybe.
so-called theory of evolution, you know, I mean, there are many people who present evolution as a fact and not a theory.
Okay. Fact,
Like Richard Dawkins,
fact, I
for
think,
example.
perhaps means something differently to you and I.
What is a theory? What is a fact? What is the definition of fact?
Fact is a statement that is measurable. So.
Well, so someone once, I once
Am
read.
I 6 feet? If I said I'm 6 feet tall, that would be a fact.
Right.
Because we
right.
could measure it to determine the answer, and we would measure it and find out that I am not in fact 6 feet tall.
Well, let me ask you a more practical question. There is a move by the federal government to ban smoking on all campuses across the United States, outdoors.
Yes.
Has that happened at MIT, to your knowledge?
Not that I know of.
Well, that's good. Now listen, I think that's it. Oh yes, we're all finished almost. Thank you for coming on.
Yeah, thank you very much for having me.